right, thanks folks. Thank you for joining me in this first virtual Bsides. I'm super excited. This is my first time speaking actually at Bsides. I've volunteered for a few years and I've talked to a bunch of the con organizers because they help me out with DefendCon. So I'm super excited to be speaking to you today on MQTT security, tiny protocol with big vulnerabilities. All right, well, so let's get started. Oh, maybe let's get started. Slides. Virtual, there we go. There, now we can get started. A little bit about me. I am a principal security engineer in IoT, which is why I'm talking to you today about MQTT. I've worked in security for about 20 years now. I've worked in IoT for about 45 days. And the reason I bring that up is there are probably people sitting in the audience right now who may be more junior to the industry, or maybe they're starting in a different niche of the industry like me. And maybe you've thought, I'm too new, I don't have enough to speak because everybody already knows what I know. Well, about 2 months ago, I didn't know what I'm about to present on today. It wasn't part of my job. And so I've been spending the last few months getting really familiar with IoT and applying my background in security to that new space. So the reason I bring that up is so that I hope folks in the audience who are thinking that you don't have enough knowledge to speak, or you don't want to put yourself out there, encourage you to join the community and help folks that maybe don't know what you already know right now. Some of you who know me probably know me from DefendCon. We are in a break year, which actually kind of worked out because COVID messed everybody's plans up. So kudos to the con organizers at Bsides for pulling off this virtual event. It's amazing. We are hoping to bring DefendCon back in 2021 as a virtual event, but we're still ironing out all the details because it is a lot of work. I'm a US Air Force veteran. I spent some time with the Army. I've done counterintelligence, missile defense. I have done basically a ton of different things in the military and federal space. And my hobbies are open source information collection. So you'll see some of my talks on disinformation is more traditionally what I speak on. I also do photography and I raise a small child, which takes an awful lot of my time. So I have a full plate and I'm happy to be able to be here to do this on a weekend while my husband is guarding my child. So that's always very exciting. All right, so the first thing we need to figure out is what exactly is the Internet of Things. Now there's a bunch of different definitions and I think they overlap a bit and it causes some confusion. Basically, the most common definition is that it is a set of physical things with embedded software or sensors that's then connected to the internet to talk to other things. So the most common explanation of this is like your home automation system. So your smart lights, your smart doors, that's where most people kind of get exposed to Internet of Things. But what I think a lot of people don't realize is that it's actually much bigger than that. So you have a huge medical industry that has an Internet of Things presence, manufacturing, power grid, nuclear power plants, anything you can think of. There's now a military Internet of Things. So there's a ton of applications of IoT. Sorry guys, this isn't for me, so it's a little wonky. There's a ton of IoT implications that span more than just whether I can turn on and off your lights at home. This technology reached $100 billion in market revenue in 2017, and it's expected to grow even more than that in the future. So what is MQTT? MQ Telemetry Transport, or Message Queuing Telemetry Transport, is an open standard, basically designed to be lightweight, publish and subscribe. It's a way of getting IoT devices to talk to other IoT devices. And the reason it was invented is that IoT, unlike traditional computing environments, often operates in areas of high latency, low connectivity, where there's not a lot of power and there's not a lot of ability to get messages to other things because you never know what's really going to be online or not. It's designed for devices with really small footprints, right? Really small code footprints, really low power. These things can exist out in the environment for 5 to 10 years on a battery, and they may never see the inside of an actual physical place. They are put out in a farm somewhere and forgotten about. So what are the benefits of MQTT? It's scalable. You can connect a bunch of devices to it, and that's really big because when you're dealing in IoT, you're usually dealing in hundreds of thousands, if not millions of devices at the same time. It's also packet agnostic, and what that means is that It's basically just a sender. Think of it like a mail envelope. I can put anything I want inside the envelope. As long as I have the correct addressing on the outside, I know it's going to get to my destination. And that can be text messaging, that can be binary data, program data. It can be really anything, which is good, but it can also be really bad. It's also really reliable. So unlike more traditional low footprint protocols like UDP, which is fire and forget, and you may not know if your end destination gets the message, MQTT actually has reliability built in through quality of service levels. So you can actually set it so that you know the end destination will eventually get your message. It's also decoupled in design. And what that means is that sometimes the server's offline, sometimes the end device is offline. They don't have to be online at the same time, which is really important when you're thinking about these geographically distributed devices in areas that may not have great connectivity. It's also really, really efficient. It's very, very lightweight. It's designed to operate in networks that have very, very low bandwidth. And it also is designed to operate in areas where it has high latency. So there's some key ideas you need to understand about MQTT. And the first is a publisher. So a publisher is exactly what it sounds like. It's somebody who publishes a message. Usually this is the actual thing, right? The actual thing in the environment, like the light bulb or the sensor, that actually is sending information to some kind of controller. That's pushed through what's called a broker, which acts as a middleman. It sits in the middle of, if any of you guys have done the Network Plus exam, you remember the star network design, very, very similar idea in this. Broker sits in the middle. It's accepting published messages from end devices. Now, on the other side of that transaction is a subscriber. So you can think of this like if you have Ring or Nest, you have an app on your phone. It is the subscriber to messages about your light bulbs or your garage door. Basically, it's the thing that controls the messages in the infrastructure. And then there's something called topics. And topics you can think of like sections of a newspaper. Imagine if you could subscribe to the New York Times, but only the sports section or only the finance section. That's what you can do with MQTT. Only subscribe to the information that you want to know about, and that way you can act on that information without getting spammed with a bunch of other information you don't really care about. So it's history. It was created way back in 1999 by engineers from IBM and Eurotech. It was created for oil pipelines. So again, that's a very traditional use case, right? You've got these oil rigs out in the middle of basically nowhere. They often operate with satellite connections, which are incredibly lossy and bandwidth constrained. So there had to be a way of getting that information back to the controller that was usually in a mainland installation. So they created this protocol that's super lightweight, but the problem is, just like when HTTP was first invented, they really didn't think about security because that just wasn't a concern for them at the time. So authentication wasn't even really thought of until very recently in version 3.1. So this is basically what it looks like. It's a very, very simple idea. So this is an IR sensor. You could use this. I have one that monitors the water level in my cat's water dish because it's in our back room and I'm really bad about remembering to check it. So now I have an IR sensor that sends me an alert when it gets to a certain level so that my cat doesn't die of dehydration because I am a terrible human and that would probably happen. In the middle is a broker, and the broker, like I said, acts as the middleman. Think of it as like a little mail person sitting in the middle of the network directing all the traffic. Below it, you'll see a database. This isn't required for MQTT, but in any large MQTT installation, you'll probably see one. This allows the broker to store and buffer a lot more messages than it would if you were relying on the on-device broker. And then on the far right, you'll see a smartphone. This can be a smartphone, it can be a control unit, it can be an automotive control unit head. It can be really anything that has the automation programming to understand the message and act on it. And you'll notice that the IR sensor is a publish under sensors and distance. So it's in a group of topics called sensors underneath that distance. And what that is if you think of it kind of like your folder structure in a file system on an operating system. You have a big group, a smaller group, an even smaller group, and that way it's easy to categorize and understand information. So use cases. Where is MQTT used? Honestly, it's used just about everywhere IoT is used. You can think of it in automotive instances, manufacturing instances, power grid. healthcare, cardiac monitors. If you can think of an IoT instance, odds are MQTT is probably hanging out there, which is great because it allows this protocol to be very standard, but it also is bad when you start to think of some of the vulnerabilities that exist within it. All right, so let's talk about some of the types of attacks we can think on. And this is where, as I said, I'm a little new to IoT, but the good news is for those of us who came up, older than we care to admit, security doesn't really change that much. It just is a different application of the same old principles. So when we start to think of MQTT, we look at denial of service attacks. We look at poor authentication. We look at poor authorization. We look at software vulnerabilities. MQTT, the broker, is just an application like any other application. Transport security. How do we actually protect the communication across the wire? Because remember that MQTT was not designed to be secure. It has no native encryption in the application. So all of the encryption has to be on the wire. So denial of service. Basically, I can do this by seizing all the available broker connections. So basically just spamming the broker and consuming its ability to respond to authorized clients. I can also spoof client IDs to bump legitimate client IDs off. So one of the recommendations is that you have unique client identifiers, which is great, except if I can get your client identifier and get to the broker first, it'll actually bump an authorized client off in favor of my request. You can also do multiple unauthorized publish and subscribe. So this assumes that you have some low-level credentials on the broker, but you just keep trying to subscribe to topics that you're not authorized to, and eventually the broker falls over. And then there's malformed packets. This is, again, a very typical application security attack. If you just start throwing bad packets at it, eventually the broker croaks, falls over, and then because it's a star type network, if you make the broker fall over, everybody else falls over too. Poor authentication. So again, like I said, by default, there is no authentication. They didn't add support for authentication until version 3.1. Version 5 is out now, but it's still not required. You can still, when you install it, you don't have to put any kind of authentication. And the bad thing is that even if you do go the extra step of deploying authentication, it's sent in the clear. There's no native support for encryption. When people deploy these, think that they're deploying them to multiple millions of devices. So doing individual user credentials can be really, really hard. So what happens a lot of times is that usernames and client IDs are sourced from really easily guessable information like serial numbers or MAC addresses or things that are very sequential. So user 1, user 2, user 3, things like that. You could also have a lot of default device credentials. So even when people are trying to do the right thing with authentication and using certificates, a lot of times they'll just use the same certificate for every single device on the network, which if you're sitting in the middle of the network or you're able to gain access to the hardware, you can then grab that certificate and become an authorized user. All right, so we've talked a lot about authentication. Now let's talk about authorization. I think if anybody's worked in an enterprise environment, you know that permissions are hard. Permissions are a lot of work, and especially on a network of billions of devices with hundreds of topics, it takes work to get really, really good permissioning. And unfortunately, like in our traditional compute environments, that doesn't always happen. So a lot of times what happens is that they'll just allow any authorized person, any authenticated person to just subscribe to all the topics. So that means if I can get a very low level, let's say I take over a light bulb, but I'm in an industrial setting, I can maybe get topics on the manufacturing robots, or I can get information on the power conduits or things that I'm not really supposed to be able to have as a light bulb. It also has a lot of support for wildcards. By the way, that's my cat. Sorry, she's fine. She's not dying. She just acts like it. So wildcards are plus and hash. So plus you can figure out if I don't know the root of the folder, I put a plus. Hash is if I don't know the subdirectories. So the reason it was designed like this is, again, it's supposed to be really easy to use, which makes it really easy to hack, unfortunately. So the other problem we have is poor device segregation. When I'm deploying something in an IoT environment, a lot of these networks are legacy. They came from the idea of industrial IoT spaces where your network was protected by the fact that it really wasn't connected to the wide web. It might have been connected to an internal network, but you assume that anyone who could get into the building probably had access to be there. Then we talk about software vulnerabilities. So the MQTT broker doesn't have a ton of discovered vulnerabilities right now. I expect that as it becomes more widely known and more widely adopted, there'll be more CVEs published on it. But the vulnerabilities that do exist are actually quite severe. Things like being able to gain all kinds of credentials or information disclosure. So anytime you have an application that's functioning like this, you have the possibility that that application itself could be taken out. You also have vulnerabilities in data aggregation and facilitation dashboards. So if you use, like I said, a home automation solution or a home router, a lot of times they'll have an admin console that aggregates this data for the user, and that admin console may not actually have good authentication and authorization. So you can log into the dashboard and then publish and subscribe to MQTT messages and topics. So transport security, we talked a little bit about this. Traditional MQTT environments are clear text over the wire. So you really have to depend on the transport layer security, which is hard in a small footprint device because encryption is costly, especially modern encryption suites like TLS. They are very expensive to run over the wire. So what happens is then you get these lightweight versions of cryptographic algorithms, and some of them are really, really great. Some of them are less great. Some of them, by lightweight, they actually just mean really cryptographically insecure. Uh, One of the problems you run into, especially when you're using the device itself to generate a certificate, is that because it's low power, it often lacks sufficient entropy to create truly random numbers, so the certificates become easily guessable. Basically, just doing crypto without a lot of overhead compute is really hard to get right. So where's the problem? Who cares if I can publish and subscribe to MQTT? We assume that people are doing the right thing and, at least doing the basics of security. For those of you chuckling in the background who've been doing security for, longer than 15 minutes, you'll know that assuming that users are doing the right thing is probably a bad bet every time. So we go over to a fun tool of hackers in IoT everywhere, Shodan, and we can search for IoT devices that are listening on port 1883. And that's the default port for MQTT brokers who operate without SSL. We can also see if we can attempt to connect to sysbroker, which is basically the default root of most MQTT brokers. And if I can connect to that, I can pretty much be assured that I can connect to everything else. So when I did a scan of MQTT on Shodan, I came up with roughly 38,000 results. These are MQTT brokers across the world that have absolutely no authentication whatsoever. We'll let you publish and subscribe to topics from anywhere on the internet, no questions asked, no passwords required. When you think about it in terms of total devices, that number's not really that big. But when you start to dig into these, you'll see that these are healthcare instances and power grids and water dams and things that could potentially have very negative consequences if you were able to publish and subscribe to messages that you weren't supposed to. So now that I know this, I was kind of like, well, okay, I've got these 40,000 devices roughly. Well, what do I do with it? I'm too cheap to pay for a Shodan subscription. I think it's a fantastic tool, but it is quite pricey if you're gonna be running a lot of queries. So I found this tool called Masscan, and I am super in love with it. It's like Nmap on steroids, and it's legitimately designed to scan the whole internet. It's published by Robert David Graham. You can get it at that GitHub link. It also works with common Nmap syntax. So if you have used Nmap in the past, this will be a really easy learning curve for you. This is where I get to do my PSA of the talk. Just because you can scan the whole internet, don't scan the whole internet. For folks that are starting out, this can be really tempting. I mean, even folks that have been doing this a long time. Remember that you should really only be scanning things that you have access to scan, hopefully with a written pen test agreement and a clearly scoped agreement on what you can and can't touch. There are parts of the internet that react extremely poorly to being scanned. In 2016, there was a whole kerfuffle about people were trying to hack one of the state's election boards because they got an Nmap scan. Maybe they were trying to hack it. Maybe it was a board script kiddie. I don't know, and neither do they, but nobody wants suits at your door asking why you tried to scan the MQTT broker for the power grid in Alabama. So, but hypothetically, if you work for a large cloud service provider, you might have access to a lot of IP addresses that you are within your purview to scan. And so that's where Masscan can be really useful. Same if you're a pen tester working on one of these engagements with a cloud service or a very, very large enterprise environment, Masscan can be super useful. All right, so this is my really boring screenshot of my Masscan. This is where I confess that I made a typo, and CIDR notation is real fun and real finicky. So if you make a typo, sometimes instead of scanning 64,000 addresses, you can scan 16 million addresses. So shame to me, I should not have done that. That was an oops, but you know, now I have the data, so I can't give it back, so that's fine. So basically what you can do with this is you can figure out, okay, from that data, I had 225,000 hosts that were alive, 225,000 hosts that responded back to me and either said, yes, that port is open, no, that port is closed. Of those 225,000, I had roughly 2,500 hosts that had either port open, and then about 1,000 hosts that had specifically port 1883 open. Now, not saying you should disregard the remainder of those machines on 8883, but if you have limited time and limited ability in your test environment and you really want to go after the low-hanging fruit, I'd recommend sticking with the non-TLS version because it's just a little bit easier to hack. And so you want to kind of take care of those things first and then move on to the harder challenges. So now that I know sort of the hosts I would want to scan, I have to become really familiar with how MQTT actually responds. And how it responds, much like HTTP, is with response codes. And this is the list of the response codes. And the goal, or the thing you hope to get, is 0 connection accepted, right? So I wrote this little Python script. This is just a snippet of it. Basically, you can iterate through a list of IP addresses, connect to the MQTT port on 1883, see if you get a reset or an RC code 0 back. And if it is, then that is probably a host that will allow you to kind of dig in and manipulate stuff around. Now, that's not to say that you should disregard any other of these return code responses, because, for example, if you get a number 2 code back, it means the connection was refused, but just because your identifier was wrong. So that means that they have some kind of client ID scheme that they're enforcing. If you're able to figure out what it is, it's possible that that's all they're doing is just a client ID. One of the interesting things about MQTT is that you can set a username with no password. So just because their username or a client ID exists doesn't actually mean it's protected in any real way. So you may be able to either guess from a serial number or guess from a MAC address or just start trying things until it lets you in. Same thing with bad username or password. You can just start trying a lot of passwords. I'm sure if you have been around security for a minute, you'll know that password 123 and admin and all of those things are still pretty much the same. So don't just disregard them unless you're on a really limited time engagement. But for this particular example, I accepted just to kind of see what I could muck around with. So I spent some time playing with Paho MQTT, and I'm much more the engineer that likes to grab other people's code and see if I can modify it than actually write my own code. That's just really more my style because I'm a little bit lazy. And I found this awesome tool called MQTT Pwn by Akamai. Highly recommend downloading it if you're going to get into this area of research. It's so much fun. And it's also really easy because there's 2 variants you can use. You can use it locally with Python, or you can use it in a Docker container, and the Docker container is magical. I love it so much. I cannot understate how much I love this tool. It has modules for brute forcing username and passwords. It has a module for sort of creating your own botnets. It has a module for topic enumeration, reconnaissance. Basically anything you'd want to do in the MQTT space is probably in this tool, and it's just really well written. So one of the things I started to do was look at topic enumeration because I specifically wanted to know what types of information I could grab from these hosts that were allowing me to connect to them. So this is just a snapshot from one of the services that I was able to grab kind of in the middle, mainly because this host, the top ones were the top ones were kind of very specific about what kind of host it was, and I didn't really want to put that in a slide deck. But you can see here that I can subscribe to all of the messages received in the last 15 minutes, all the messages sent in the last 15 minutes. So that would be really useful information for me. It allows me to kind of figure out what this actual machine does, what the broker is doing, and then also what kind of information I can get from it. So, real world use cases. Now, I could talk to you today about really important things like power grid, or how, hospitals could be overtaken by, rogue publish messages, how dams could be opened in flood cities. But I don't want to talk to you about that. Today, I want to talk to you about something even more important. I want to talk about the Internet of Cows, because I feel like this just doesn't get the news coverage that it deserves. So this is a true story. I'm not making this up. You can Google it after this talk, Internet of Cows. It's a real thing. Cows are becoming increasingly more connected to the World Wide Web. A particular company makes a device that is basically like a remote cow steering device, if you can think of it. It sits on the cow's back and sort of nudges them when they get off piste. So the GPS will kind of send back to the controller, and it's like, hey, you're not supposed to be there. And it nudges the cow, and the cow walks away. A lot of these don't have the best security, don't have the best implementation of these protocols. And so imagine, if you will, that you could disable the tracking and guidance system. So now you have cows sort of loose on the prairie running around. Or maybe, you just do it to annoy the cow if you're a really crappy person. But what if I could get access to the guidance system and drive these herds of cows and create the Internet of zombie cows? Think of that. Think of that when you go to sleep tonight, about why IoT is important. Do you want to get attacked by zombie cows? No, you do not. So that's why IoT security is so very important. All right. But the good news is it's getting better. Don't worry, it's in the cloud. Everything is awesome in the cloud. Everything is awesome. It's in the cloud. There is part of that that's really true. Because a lot of devices are migrating to cloud services are able to make security easier to onboard to and less friction. TLS and SSL enforcement is much more broadly adopted by people who are entering this space because they make it a requirement to onboard to most cloud service providers. The better MQTT, you'll notice I make this typo a lot. It was a typo in the slide or in the topic. I am really dyslexic and I do not well double comments. MQTT broker defaults are a lot better in the cloud because they're managed by cloud service providers. There's also the ability to use a lot more detection and automation because you get access to cloud services that monitor your logs and send alerts and can kind of protect you from DDoS on the cloud layer. So it is better. There are things that are better, but there are potential downsides. Cloud environments are highly configurable, which is good. That's a good thing, right? We want to make it easy for the customer to join and onboard to the cloud. But if you worked with users, you know that if you give them the possibility to undo security, there will be a situation where it happens. So the cloud kind of does make it easier to do bad things at scale. It means that you can now connect billions and billions of devices and then turn off all the security, which is bad. You can imagine that systems may not be designed with the appropriate redundancy. If you're relying on the cloud for your MQTT broker services, say in a factory, you really have to think about what you do when the cloud is down, and if there's a cloud outage. It's something that people are really starting to grapple with now as they move their IoT installations to the cloud, and it's something they have to be really careful with when they're designing their systems. So, key takeaways. MQTT is a lightweight, widely adopted protocol used for IoT publish and subscribe actions. It can be and often is insecure because it doesn't support security natively, except for username and password, which is sent in clear text. When deploying IoT devices with MQTT brokers, it's highly recommended that you use over-the-wire encryption and also on-device encryption, because if I can get your username and password by getting one of your devices, odds are I can still get to your broker. The ideal situation is that you have very specific access control policies and device certificates per device so that your light bulbs can't access your garage door and your garage door can't access your coffee pot, and so on and so forth. Resources. I will be putting the slides up on my website, which is very, very tragic right now. It's really just a place where I dump my slides. But Masscan is the tool that I used to enumerate some of these hosts. MQTT pwn I talked about, that's the repository where you can get it. I also, if you're looking to get into IoT and you really haven't had a chance, I really, really love this Instructables document. I think it's 4 or 5 parts. It walks you through creating an IoT device with Raspberry Pi, setting up an MQTT broker, and then hopefully once you get that set up, you can use MQTT pwn and kind of play around and figure out the vulnerabilities in MQTT yourself. You can follow me at @securitychick on Twitter, and that is the end of my presentation.